resultant grade. Resultant grade. The table. On page 70. Table 3. Table 311. Table 311. Part 3. Grid length limitation. Grid length limitation. Grid length is the distance between two grid change points. What's grid change points? What's grid change points? These grid change points. Grid change point. Grid change point. Grid change point. The distance between two grid change points has a maximum and a minimum grid length. Minimum grid length is to avoid hump profile. Hump profile. What's hump profile? Hump profile. Hump. This is hump profile. Hump profile. Hump profile. Avoid minimum grid length to avoid hump profile and assure continuity of alignment. Slope length should not be too short. Should not be too short. This is hump. This picture shows a hump profile. Hump profile. Hump profile. When you drive on this road, can you feel comfortable? Why? Up, down. It's not comfortable. Minimum slope length. We use 9 to 15 seconds driving distance. The minimum grid length is calculated by the time and the speed. Time multiplies speed is length. The time is from 9 to 15 seconds. For freeway, we use 9 seconds. This is the minimum length of different design speed. Different design speed. This is for highway. This table is for every road. It's for every road. maximum grade length. Over long grade length adverse to vehicle operation. Uphill and downhill. Uphill and downhill. Mixture of low and high speed vehicle. This is the maximum grade length for different design speed and for different longitudinal slope. You understand?
Yeah, which page?
Which page? Okay, which page? Page 67, table 37, page 67, table 37. Okay? Why? This zone is have no value. Why? This one. Because the maximum longitudinal slope of for the design speed of 120 kilometers per hour.
Should not be more.
The maximum of slope is
4%.
4%. No, this 5% is too bigger, bigger for so the maximum is 4%. For 100 kilometers per hour, the maximum is 5, not 6. Maximum length for urban roads and for long motor vehicle, bicycle, such as bicycle. This is the table. Table 8, table 3.8. Table 3.8. This is long motor vehicles of the grade, the maximum grade, the maximum length for long motor vehicles. This is in table 3.8, 3.9, on 60, on page 68. 3.9.
好，是继续。
Oh, have a rest. Have a rest. I2, I1, I2. This is very steep slope. I1 is steep, is larger, and the length of I1 it approximate the maximum length. So I2 is this length, this section is a transition slope. I2 is less than I1. I2 is I1. I2 must less than 3%. This transition, I2 is transition. So I3 is greater than you understand?
Yeah.
The transition grade, the effects of the transition grade recover the speed when going uphill and relief braking operation when going downhill. Provisions is standard. Transition grade should be less than or equal to 3%, and the length should be greater than minimum slope length. What's minimum slope length? Let me see. The minimum length 60, page 67. Page 67. Page 67. Table 3.5. Page 67. Table 3.5. Table 3.5. Table 3.5 is for highway. The minimum slope length for highway. Table 3.6 is for every road. It's for every road. It's for every road. Question 1. The design speed of a class 2 highway is 60 kilometers per hour. There are two continuous grades. 5%, 400 meters. 6%, 300 meters. Is this readable? Is it readable? How to? How to calculate it to judge is readable or not readable? Reasonable. Is the grade is 6% and the length is 301 meter. Is it readable? How?
You should see the table.
How? Let me see this table. This table. Table 67, table 37. On page 67, table 37. How to calculate?
We should check first the speed.
60.
60 when the percentage is 5.
I tell you a method to judge its if is this eligible. Uh, 5%. 5%. 5%. 5%. How long? 40 meter. 6%. 6%. 300. 400. 300. Let's see this table. 5%. The design speed is 60 kilometer. Okay, 60 kilometer. 5%. The maximum length is 800. So we use 400 divided by 800 and use 6. The maximum length of 6% is 600. Okay, 600. We use 300 divided by 600. Or the result. Other result. 1. Okay. 1. So if the result is less than 1 or equal to 1, is reasonable. Is reasonable. If the result is great then 1 is not readable. It's not readable. So when the length corresponding to grade 6% is 301 meter. It's not readable. It's greater than 1. So it's not readable. It's not readable. Reasonable. It's reasonable. 1 is critical value. Understand?
Yes.
Okay. Next page. For question 2, you can finish it after the class. For a freeway at 120 kilometers per hour design speed, if its grade is 2.9% and its length is 1,775 meter. Is it reasonable? Reasonable? Reasonable?
Also, you say freeway in China, freeway equal highway. In China, freeway and highway is the same.
Not the same.
Urban road.
Highway is in America or in other countries. Highway is not different freeway. But in China, highway contains freeway.
So,
That's freeway.
so in which table we use?
So highway. This table for highway contains freeway because freeway the design speed of 120 kilometers only for freeway. Only for freeway. It's reasonable. Can you judge it? Is it reasonable?
Check.
Reasonable? $120. You can see it. Reasonable? Reasonable. Reasonable. Because the grade is less than 3%. 2.9% is less than 3%. So there is no limit for grade length. There is no limit for grade length. There is maximum. There is low maximum length for grade 2.9%. Understand?
Yeah.
So it's reasonable. It's reasonable. No limit for length for this grade. Okay. This is there are some picture for current situation of Dongwu-San section. It's a long uphill section with horizontal cap. Uphill. And this is horizontal cap. Let's see, emergency parking street. Emergency parking street. This safety alert sign. Safety alert sign. The speed limit sign. Speed limit sign. 100 kilometers per hour. Speed limit. This is lamps. Lamps for interchange. Ramp for lamp. Ramp. L is R. Ramp. A lamp. Oh, lamp. Lamp. Not a ramp.
Yeah.
Not a ramp. Ramp is for interchange. Lamp. It's reduce speed, side speed, and bumps. This is bumps. Bumps. This is the sign. Warning light. Background. Walk. Oh.
Here.
severe extent. Severe extent, so is where. Vertical alignment. Vertical alignment. This is for real freeway, real freeway, Dongbusan section. Hangzhou Expressway, Nanjing to Hangzhou, from Nanjing to Hangzhou Expressway, or freeway, Dongbusan section, at flat rolling carriage. This is one grade. There are two grades, and this is vertical cap. Vertical cap, and the radius is 20,000 meters. 20,000. The slope is 2-point line pattern. It's an uphill, downhill. It's grade. This is design specification, grade length limitation, design speed, longitudinal gradient. This is the same with as table 7 on page 7, on page 67. 3, the same as table 3, 7. Okay. This is the you can read these pictures or figures after class. It's a real expressway design. Section 3. Vertical cap. Vertical cap is set at grade change point. The effect of vertical cap is to meet the requirement of smooth and comfortable driving and the visual range. Forms. The vertical cap is circular cap or parabola. What's parabola? Parabola is y equal to a. This is parabola. Parabola. This is parabola. Part 1. Calculation formulas of vertical cap elements. We use parabola, not circular cap. We use parabola, not a circular cap. Vertical cap we use parabola as vertical cap, not a circular cap. When omega is greater than 0, omega is greater than 0. The curve is second vertical curve. When omega is less than 0, the vertical curve is crest. Omega is I2 minus I1. I2 minus I1. If go down, I is greater than 0. Or when the grade is down, the I is less than 0. When I is up, the value of I is greater than 0. So okay, this is the regulation, synthesis or the regulation condition. When I is greater than 0. When down, I is less than 0. Omega is equal to I2 minus I1. So in this condition, omega is greater than 0 or less than 0. Oh, this is less than 0 and so omega is less than 0. So in this condition, the vertical curve is crest. In this situation, omega is greater than or less than 0? Greater than 0. So the vertical curve is crest. Is set. This is crest. This is crest. This is set. Okay. This condition is very important. When omega is greater than 0, the vertical curve is set. On the contrary, it's crest. That's crest. Formula of the derivation derivation, we omit the derivation, and you can read this part after class. Formula of parabola is y is equal to this is the formula for parabola. K is R of coverage. K is R of coverage. We can get the formulas. T1, T2. T1 is approximately equal to T2. T is tangent line. The length of T is the tangent. The length of tangent line. And is the horizontal length. T is T this is tangent point. T1, T2. T1 is equal to T2. And this T1, T2 is a horizontal length. Not this length. Not this length. Not this length. It's a horizontal length, not the three-dimensional length. Not a three-dimensional length. It's a horizontal length. Horizontal length. Horizontal length T. L. The length of the cyclic, the vertical curve, parabolic curve, or vertical curve. Is horizontal length, not the curve length. Is horizontal length. The projection on the horizontal level. Not the curve length. Is the projection on horizontal curve, on plane, on plane. Our T and L are the length of the projection on horizontal level. So the calculating formula. Difference of grid omega. Length of vertical curve is length of vertical curve L is equal to radius multiply omega. Length of tangent is equal to the half of length, 1/2 of the length. External distance is this expression. What's the external distance? This one. This one. This one. You know?
Okay, so
this one. It's perpendicular. Perpendicular to the second curve. Or this line is through the center of the vector curve. Graphing value of elevation y is equal to x. This is the start point of vector curve. This is end point of vector curve. And I1, I2, omega. I1, I2, omega. Y, correcting value of elevation y is equal to x, the square of x divided by 2 times of radius. Characteristics of calculation of vertical curve elements. Replace curve with tangent. 2. Circular curve actually is parabolic. Have a rest.
yes.
Have a rest. Okay. Have a rest. Vertical curve is 4,000 meters. Please calculate stack numbers of this value. This is the calculation solution. Firstly, we get omega. L is a vertical curve, or the length of vertical. It's equal to R multiply omega. 160 meters. T is tangent, the length of tangent line is equal to L a half of length of the length of the vertical curve. Stack number of the starting point is stack number of the starting point. Vertical start point is the vertical curve start point. Vertical curve start point. The starting point of vertical curve is the stack number of grade change point minus t. The stack number of the ending point is equal to this value plus t, or
minus t.
this curve, or this curve plus L is the same. So we must get the wall stack number, the design elevation of all stack lines, or of all stack lines at the interval 20 meters. Interval at the interval 20 meters.
This step one. This step one, which step one? No, this table, the table. In the book?
Huh?
This one, this table is in the book?
No. No. In the Chinese. In Chinese. In Chinese.
Yeah, but it's, no, I said the table.
On, on page 70. It's not the same problem. It's not the same question. On 77. On 77. 77. It's not the same.
How did we get this table? How did we get this table? How? How we did we have the we have the
How? Okay. Vertical distance. Offset distance x. Also, offset distance x is the use when this is the start point, so this is 0. This is 0. This is 0. This is 0. Distance, offset distance x is this value minus this value. 8,040 and 8,540 minus 8,520 is vertical distance is calculated by this formula. R is equal to 4,000. So,
okay.
Now, this is radius 2. This 2R. What's the meaning? 2R.
2R.
Yeah.
Why is 2R? The H is 2R. This one. Use this picture to understand. H.
How to calculate the elevation slope?
We x square of x divided by 2 times radius. This one. This expression is the
elevation.
This elevation. This distance. The difference of elevation of this point and this point. This point. So we can get how to get the elevation of this point. Use x multiply I1 and plus the elevation of this point. You know? You know?
Yeah.
This point, the elevation of this point plus
Yeah.
this value, and the result is the elevation of this point. Okay?
Yeah.
Your point. So, how to calculate this one? This value. X multiply I1. The point of the eventually we will get the elevation of this point on the design speed, on the design line, vertical design line or vertical profile. So this the elevation of this point is equal to the elevation of this point plus this distance.
Yeah.
How to calculate this distance is okay.
Yeah.
Understand?
Yeah.
Okay. So you must draw a graphic. Draw a graphic like this. When you calculate. So the elevation of slope. How to get this one? Use this value. Use this value. This value. And plus what? Plus 1.5% multiply 20. Huh? Multiply 20. X is 20. What's the slope? 1.5%. Yes. Okay. Okay. This one.
Actually, the question now is how did we find 50?
Design valuation. This value is on the slope. On the slope. On the slope. Not on the curve.
But we did not write it. How can we know it?
Huh?
How we should know it? They did not give us it in the problem.
We can know it. You can.
I see. The question. The question. Here, they did not give us this value.
This value. Oh, what is this value?
Yeah.
Okay. It's a good question. I tell you. I'll answer this question. Oh, how to get this value? Okay. I forgot to express. Okay. This point, this elevation is lower. is low.
Will be minus.
The length is low. T is low. T is low. T is low. T is 80 meter. It's calculated by the formula.
Yeah.
By formula. 80. Okay, 80. 80 plus 80 multiply this slope and get the elevation difference. Okay. This is 1.2. 1.2. Okay. 1.2. So is equal to. Understand? Understand? Okay, understand. Use the T and the slope and the elevation of grade change point to get the start point, the elevation of the start point of second curve. So, understand? Okay.
We get, you say also H minus L times
This is T.
T.
T. This is the slope of I1. Just T1. T1 is equal to T2. Okay.
And now
So, we can get this one. This one. So, design elevation, we must minus this one. Minus. Minus. Square of x divided by 2 times of radius, 2 times r, 2r is equal to 0.05. Is equal to 0.0. Okay, so use this value minus this value, we can get the result. The design elevation of vertical cap or vertical cap. Understand? Understand?
Now, see, what is the sign of elevation of slope? The symbol.
Design of elevation is
H.
this is design.
No, the sign.
Huh?
Sign. Symbol. In the table. Yeah, the symbol. Which symbol? H.
Elevation with the slope.
Is H.
S.
No,
Yes.
is H. The symbol vertical distance is Y.
This is H, not Y.
Is
Is H.
Yes.
H.
And this one, and this one,
This one elevation of slope is
T or S?
is the height on tangent line.
No.
The height tangent line. The point, the elevation point on tangent line. And the design elevation is on on vertical curve. This is elevation on slope, and this is elevation of design on circle on vertical curve. Okay.
now this sign, the symbol, which symbol?
Laoshi.
Symbol.
That means the previous.
The table.
This is
Table.
This is, for example, distance. That means English word. That means x, and he said you what will be
For
the
example,
number.
For example, like this.
For example, okay. For example, for example,
It's X.
okay. This is slope or tangent line. Slope line or tangent line. Okay. This is square of x divided by 2r, and this is design elevation. Understand? How to get this? How to get this is start point. This is at start point. This is end point. Okay, start point, end point. How to get the elevation of start point? Use this is low. This is the elevation of this is low. What? And this is 80 meter. The slope is how much? 1.5%. So this is low. This is low. And the t, the length of t is can be calculated by the formulas. The formulas. Okay, this formula. The formula. Omega. How to get omega? No. I2 minus I1. Okay. R is low. So we can get this. The elevation of the start point is how much? Okay, so it's how to get this? How to get this? The distance between the start point and
Distance.
this point is 20 meter. 20 meter.
20 meters.
So we can 20 meter plus 1%, 1.5%. So we can get this the elevation of this point. And this is square of x divided by 2r. So we can get this value. Eventually we can get the design. Okay.
Yeah.
They understand?
Yeah.
Okay. Understand. The same method for other stack numbers. Use the same method. The same method.
As you say now, okay. Oh, so
If the point on this side,
so if it's like this one,
this okay,
this one,
this one.
this is the highest. Is the highest.
E is equal to T.
Yeah, yeah. So this point.
This point, how come this the elevation of this
the
point?
elevation in this point is the same. This one or is the elevation in this point?
No.
It's not symmetric.
Okay.
This point is this point, right? Is this
No. It's asymmetric. It's asymmetrical, not symmetrical. This slope is 1.5.
Okay.
This slope is 2.5.
Okay.
If this slope is 1.5, they are the same. The symmetry. But in this situation, it's asymmetric. It's not symmetry. So this one is not the elevation of the two start and end point is not the same. It's different.
But here,
We must calculate for it. Okay. Use minus t what
times
what 2 okay.
is it what you find?
You can see. Okay. If the point on the right side, okay, on the right side, how to calculate? On the right side, how to calculate?
On the right side,
On the right side.
we use this one. We take this one.
Use this one. Yes.
This one?
Yes. Use this one. Yes. If the point. Okay. The great point is 8 plus 600. If greater than 600, for example, for this one, is on this side. This is and 660 is on this side, on right side. So for this point, for this situation, how to calculate? Use this one.
You use this
Use this one.
multiply.
Uh,
Plus 20 times.
20. Yes. And this. Okay. Yes. You can this one. You can use this one. You can this point to calculate the end point to calculate, and the x is between the two. You can use this one to calculate, but x is between the two. If you use, you can use this. You can use start point to calculate 2. You can use, if on the right side, you can use this point to calculate 2, but the x is between the 2.
Oh, okay. Yeah.
You can, I extended. If you use this, if you use end point, is the same method for the same as the start point. If you calculate this point on the right side, you must extend this slope 1, the slope 1, and the x is between the two, not this two. You must use this two. X is how much? 140, 是吧？
minus t.
This is the start point, 是吧？ We take the minus our so x is 140, not 20. 20 is for this point. And the slope. And the slope is the slope valuation is this point. Slope valuation is this point. And x and the square of x divided by 2r is this. This is x. No, we must calculate this point. This point. Use this slope. And plus and minus this distance. This distance. What's this distance? Is
what? Okay. Yeah.
Understand?
Yeah.
So you can use end point to calculate, and you can use start point to calculate 2. The difference is the slope. You use which slope? If you use end point to calculate, you must use slope 2. If you use end point you use start point to calculate, you must use slope 1. Slope 1. You must extend the slope 1 and use the x. The distance is between the start point and the given point. Understand?
Yeah.
So in this example, for this example, it on the right the point when the given point on the right side, any point to calculate because the x
20.
distance x is between the end point and the given point.
Yeah.
So okay, understand? Calculate the stack arm of the highest elevation. Example 1. Highest elevation. Highest elevation. What's the highest elevation?
55.
It's
Yeah.
this point. So,
We take 55. 50. We take 55 times 55 times 16 minus 8.
minus the can see is not
It's not
the highest elevation. Is this one?
Yeah.
This one. And the highest elevation is there. Is this one? Highest elevation is there. After class, you can think this problem. Then continue. Calculate highest elevation.
Yeah, no shading.
Okay.
It is not.
As your homework, you can after class you can complete this problem. Minimum are of vertical cap. Influencing factors of vertical cap design. Cushion, enough driving time, meet the requirement of visual distance. Cushion, the formula for cushion. Travel time is not too short. Must keep 3 second travel time. 3 seconds travel time. 3 seconds at the design speed. For crest vertical curve, visual blind spot make ahead. For second vertical curve. Be light at light. If crest of vertical curve, visual this cushion, we must keep the comfortable for driver and passengers because the acceleration, centrifugal acceleration is more very large. The driver and the passengers will feel uncomfortable. So the acceleration, the centrifugal acceleration is given at we can see the textbook. On page 72. On page 72. The formula 360. Page 72. Page 72. Formula 360.
The first. Again. This is the part 2 over.
Yeah?
No, part 2. I want that to.
The centrifugal acceleration is the maximum centrifugal acceleration is 0.28 meter per square seconds. Square second. Page 72. Page 72. 8. The formula 360. And alpha is A is equal to 0. Do you see it? 0.278 meter per square of second. Okay. So we can get this formula using the value of A. The travel time is not too short. 3 seconds travel time. 3 seconds travel time. And for cross vertical curve, visual lines will make a CAD great change point. On this side, the driver cannot see the right side. On the front side. So for vertical circular curve, you can see the and on the crossing, what's on the crossing? If there is a bride on the road, bride on the road, beyond the second car. When drive. The driver of the side will be will be 被挡到啊 blocked be blocked by the bright so the driver cannot see this zone and on the right in the light when the driver must turn the light, the front light to turn the front light to 照亮这illuminate to light the road so is a problem. One problem, two problem, three problem. For first car, for second car, for third car, in the light.
The third case.
Huh?
The third case.
Third case.
Yeah. Third case. The bridge.
Third case.
Yeah. If
this is the bright.
Yeah. If the car is coming.
Coming.
And there is another car coming here.
In this door.
Yeah. Another. The car is coming.
Not in this. Because this is the beam. This is the beam of the bright. This is a beam. The beam of the bright will block the side. Block the side. So the driver cannot see this area.
You cannot see
this area.
You cannot
So
see.
it's not safe.
This one.
Not safe.
Where is the car? Where will be the car?
Car or truck.
Yeah, where will be the truck? Should be here?
Here.
Should be here?
Yes.